So here the energy is going to be conserved. So the change in potential energy is going to be opposite of the change in kinetic energy. And the change in potential energy is related to the potential. So using this, we could probably find the potential here. So delta PE, which is the change in the potential, is going to be equal to the charge Q, which here is the charge of the electron, times delta V, which is the change in the potential, which is equal to negative the change in the kinetic energy. Well, using this, we can solve for delta V, which is going to be equal to minus delta KE divided by the charge of the electron, Q. Okay, well, we are told that the electron is starting out with a velocity v of 6.0 times 10 to the 5 meters per second. Well, if it's going from that to rest, then delta KE, which is the initial kinetic energy minus the final kinetic energy, is just going to include the initial kinetic energy, since at rest, the final kinetic energy is 0. So this is going to be equal to, since it's initial minus final, 1/2 the mass of the electron, which is 9.11 times 10 to the minus 31 kilograms squared, times the velocity squared, so which is the initial. Okay, and then this is going to be divided by the charge of the electron Q. So plugging all these values into this expression, we find that this is equal to minus 1.0 volts V. We'll box that in as our solution to the question.